Well, here we are. It is now about 3 a.m. And I am just now starting to film here, and I hope to get done by 8 with all that I want to get done. There's probably about 30, 35 videos to film between now and then edit and then put it all together. But let's get started. This is the 2022 AMC 10A problem 1. It was also the 12A of the same problem. What is the value of? Okay, this should be something that you're kind of quick at, right? When you have 1 over A over B, that's simply the reciprocal of the denominator. So you're going to have 9/3 plus 1/3 is 10/3. That's now 3/10. Then you're going to have 30/10 plus 3/10 is 30. This 3 right here becomes 30/10. 30/10 plus 3/10 is 33/10, but you're flipping it. So it's 10 over 33. As you're writing it, change the 3 to 99 over 33, 109 over 33D. Let's get to the next problem. Then we get on to 2022 AMC 10A problem 2. Mike cycled 15 laps in 57 minutes. Assume he cycled at a constant speed throughout. Approximately, meaning we're not going to get an exact, how many laps did he complete in the first 27 minutes? So you might want to think about his laps per minute or minutes per lap. So if you do laps per minute, it would be 15 over 57 laps, and then you could make it per 1 minute like this. If you want, you can divide by 3 here. You will get 5 over 19 laps per 1 minute. Okay, then what? Then you can do times 27 because he had 27 minutes. So it's going to be 27 times, this is about 1/4, and this is close to 28. So 28 times 1/4, approximately 7. You could calculate if you wanted to a decimal, but because these values are fairly far away, you're not going to probably get farther away from this value in particular. So let's get on to problem 3. And that will bring us to the AMC 10A problem 3 from 2022, also the 12A problem 2. The sum of 3 numbers is 96. So we could say something like A plus B plus C is 96. The first number is 6 times the third, but then it's going to put the third in terms of the second. So we're going to call it B plus. The third number is 40 less than the second, so it'll be B minus 40. And then the first number, A, would be 6 times the third number. So you're going to get 6B minus 240. So then that's 6 times this, if you will, and this is going to equal 96. Now, what does it ask for? What is the absolute value of the difference between the first and second numbers? So you're going to want 6B minus 240 minus B, because these are the first 2 numbers. So if I do 6B minus B, we want the absolute value of 5B minus 240. Most likely that's going to switch because the 240 is probably, we'll just see what we get actually. So here we go. We've got 6B plus B is 7B plus 8B. 8B minus 240 minus another 40 equals 96. I'm not even going to bother to combine them, which is what I did on my paper as well, meaning I took it for myself, not officially or anything like that. So then I would just divide by 8 right now. So you'll get B minus 30 minus 5 equals 12. Take the 35 over there to get B is 47. 5 times 47 is 235 minus 240, negative 5, but absolute value. Get E, win a prize. Let's go to the next problem. If you got a chance to watch the final advice video that came out a few days ago, I did tell you that there's going to be some problems you need to be prepared to skip. This might have been one of them for you. It's an early one, but it doesn't feel comfortable. Let's see why. In some countries, automobile fuel efficiency is measured in liters per 100 kilometers, while other countries use miles per gallon. Suppose that 1 kilometer equals m miles. So 1 kilometer equals m miles. And 1 gallon equals L liters. Okay, which of the following gives the fuel efficiency in liters per 100 kilometers? So our goal is some kind of liters per 100 kilometers. Okay, for a car that gets X miles per gallon. And initially, you probably just think this is going to be conversion factors. So we'll write X miles per 1 gallon. And then you're like, okay, what do I want to keep? What do I want to get rid of? And usually when you play this game, the idea is that you want to get rid of the units, not the number values or whatnot. So if I want to get to liters, I'm going to want, but you kind of weird because you want liters per 100 kilometers. And that's what's going on is it's inverted. This is like a volume and this is a distance and this is the volume up top and the distance down below. So it makes it kind of awkward here. Rather than target the gallons for removal then, let's get rid of the miles first, I guess. And we'll put miles down below so it cancels. And we want to use this conversion here. 1 kilometer equals m miles, so I'll put m here and 1 kilometer there. So now what do we have? X times 1 is x. We now have x kilometers over m per m gallons. All right, so now what? Okay, liters. I guess I want to do the liters next. Liters, L liters is 1 gallon. So we'll put times, and I want gallons up and liters down below. And it's L liters and 1 gallon. So now gallons cancels. So now what do we got? We have X kilometers per ml liters. Okay, so we want liters per 100 kilometers. This is a ratio. You can flip it, right? So you can say we use LM liters per X kilometers. Okay, you could also say that you use, this is the trick here, LM over X liters per 1 kilometer, right? And so now what? If we want liters per 100 kilometers, this is also where it's tricky. Because you're kind of like, oh, well, shouldn't I multiply these both by 100? And you're like, but wait, wouldn't the hundreds cancel? And so it gets kind of weird. And what you're going to end up doing is actually just that, though. You're not going to cancel them. You'll do 100 here and 100 here, and you can see that this is 100 kilometers, which is what you want, and your liters is 100 LM over X, which is answer choice E. You could also say if you use LM over X liters when you go 1 or per 1 kilometer, well then think about it. How much would you use per 100 kilometers? Wouldn't it be 100 times that much logically, right? If you're using this much for 1 kilometer and you go 100 kilometers, you'll use 100 times that much. You could also have thought of it that way. Both ways get you E. Let's get to problem 5. And now for the final problem of this rapid fire set. The 2022 AMC 10A problem 5. Square ABCD has side length 1. Where is it? Oh, well, we don't have it, so we better draw it, right? So we've got square ABCD, something kind of like that. We'll say A here, B here, C here, D here. Points P, Q, R, and S each lie on a side of ABCD so that APQCRS is an equilateral convex hexagon with side length S. What is S? So let's see, if I put P over here, about here, and then Q, and then C, and then R, and then S, it must go kind of like that. If you tried to put it at the halfway point, it wouldn't work because AP would be half a side length, but PQ would not match with that. It would not be the same length as the half the side length because Pythagorean theorem and stuff. So P is going to be a little bit past the midpoint, And then Q will be a little bit before the midpoint of BC, about here. R will be similarly the same distance from C as P is from A. So R will go here, and S, let's just kind of draw what we have. We have APQ, CRS. And it will look something like that. Okay, so now we know the side length is 1 of the original square. It wants to know the side length of this. Okay, do not assume it's regular. It doesn't claim that, and it's definitely not, and we'll see that in a second. So instead of using S, I'm going to call it X. I never use S. I don't know. It looks like a 5. So then this is X as well, but since the side length is 1, we know that this is 1 minus X. And since this is also 1 minus X, you have a 45, 45, 90, which means 1 minus X times radical 2 is going to equal X. Then distribute the radical 2. Why? Because the side length times radical 2 is the hypotenuse. So you get radical 2 minus X radical 2 equals X. Move the X radical 2 over. Radical 2 equals X root 2 plus 1. I can see that I'm going to be factoring it out in a second anyway, so I factor it in advance. Divide by root 2 plus 1. You're going to have root 2 over root 2 plus 1. Multiply by the reciprocal. And what is this right here? It's 1, because it's a squared minus b squared, and a squared is 2, and b squared is 1. 2 minus 1 is 1. We don't care. Root 2 times root 2 is 2. Root 2 times negative 1 minus root 2. Answer choice C. Let's get going to problem 6.